Hey guys, okay, I'm going to try to make a quick video of 5-6 transformations of quadratic functions. Alright, let's take a look at a couple things here. Let's see, there we go. Okay, so a quadratic function is transformed through its vertex form. Okay, that's really how we're going to be doing it. We're going to be doing it by just interpreting this vertex form here. So let me point out a couple of things here. A, right, is our stretch or shrink, and if it's a negative, it reflects over the x-axis. So A has two roles. So for example, if we have -1, we're treating it as two parts. Negative, which is the reflection, and then 1 is the stretch or shrink. We're going to see that in a minute. H is a horizontal shift, but remember, we changed this when we pull this out. So if this was -2, it would be a shift to the right. If it was +3, it'd be a shift to the left. And then vertical shift, which we keep. So if this was +4, we'd shift up. If it was -2, we shift down. Okay, let's take a look at a couple of examples. Make sure you guys can see that. Alrighty, so we got this guy here, and let's see if we can figure out its reflex and its transformation. You know, if it reflects, if it stretches or shrinks, goes to the right or left or up and down. So I have this negative here. I wrote this up here so we can compare. A is our stretch or shrink, and if it's negative, it reflects over the x-axis. So this is a negative, so it reflects over the x-axis. I'm going to write here, reflects over x-axis. Okay, now, you see the way we don't have a number there here. So there's like an imaginary 1 here. So as a result, it's not going to stretch or shrink because it's only going to stretch or shrink if it's more. It's going to stretch if it's more than 1, and it's going to shrink if it's less than 1. But 1 has no stretch or shrink. So no, let me draw these lines here, no stretch or shrink. Now we want to know if it's going to go left or right. Well, that's -3. Remember we said that's opposite. So it's going to shift right 3. Then K is vertical shift, and it's going to shift up 5. Okay. Let me do that again. There's this example. Can we see it? There we go. All right. This is 2/5. A is 2/5. So we're going to have a shrink, but it's not negative, so it's not going to reflect. No reflection. Okay. 2/5 is a shrink, so we have a shrink by 2/5. And then I got +1 here, so we're shifting left. Shift left 1. Now notice that K is missing. The K term is not here. So there is no vertical shift. For the record, the vertex here, if I were to write out the vertex is -1, 0. Okay, let's go to the next one. And the last example. I know I'm doing these a little quick, guys. We're kind of running out of time. So, write a quadratic function in the form of f of x equals x squared, or y equals x squared, which is transformed by a reflection across the x-axis, a shrink by a factor of 4/7, a horizontal shift of 2 units to the left, and nothing for the vertical shift. So now I have a shrink of 4/7. So I'm going to say that A, so if I rewrite this here, watch how I kind of like to do this. So A is a shrink of 4/7. And then it reflects over the x-axis. So sorry for going backwards. So that's a shrink. Now I'm going to reflect over the x-axis. So I'm going to cross that out and make this a negative. Then a horizontal shift of 2 units to the left. Remember we said it's opposite. X plus 2 squared. Now, it doesn't mention anything about a vertical shift, and there wasn't one here. So that's it. I am done. That is the answer. Okay, guys, I hope you guys found this video helpful.